Hey, hello and welcome to today's GFG problem of the day. Hope you're doing well. So let's do this problem, n queens problem. Okay. So what the problem is saying is we'll be given an n into n chessboard. Okay, an n into n chessboard, and we'll be given n queens. Okay. Okay. And what we want to do is we want to place the n queens on this n into n chessboard. For example, in this case, it is 4 into 4. Okay, n is 4. 4 into 4. Okay. So we want to place the four queens. Okay. In such a way that no two queens attack each other. Okay, no two queens attack each other. So how can we say that the two queens are attacking each other? For example, let's say one of the queen is placed here. Okay. So another queen, the next queen, she cannot be placed here because like if the two queens are placed horizontally, then they will attack each other. Or if the two queens are placed vertically, then they are going to be again they can attack each other, or like this way diagonally also the queens can attack each other. So for example, so this queen cannot be placed. For example, this queen cannot be placed here because these two queens can diagonally attack each other, or for that matter here also, right? These queens again can attack each other. Okay. Okay, I cannot place here because these queens can attack each other this here, same like this. So it is going to be like this, something like this, and this in this way. So if we place on these lines, right, the queens can attack, and hence we cannot put the two queens, right, or two or more than two queens in these positions. Okay, so I hope you have got the problem. Okay. Okay, now for example, let's see how we can place the four queens. There'll be four queens, right? So what we want to do is we want to return all possible combinations, okay, of the four queens being placed in these chessboards in such a way that they don't attack each other. So what are those ways, right? So let's see, for example, let's see if this is for example, if I place queen 1 here, so can I place queen 2 here? Definitely no, right? They will attack. Can I place it here? Can I place it here? No. Or here, for that matter, they will attack each other. Can I place here? No, I cannot, because they will attack again each other. So what I'm going to, where can I place? I can place here. The second queen I can place here. Okay. So in no way these two queens can attack each other. Okay. Now I have two more queens to place. Okay. So can I? No, I cannot. The third queen I cannot place here. I cannot place here. I cannot place here, or I cannot place here. So this combination, it is not possible. So I'm going to backtrack. I'm going to backtrack this particular queen. Okay. And maybe I can try it this way. Here, can I place here? Can I place this particular queen? Yes. Second queen I can place here. And I'm going to check here. Okay. Can I place a third queen here? No, I cannot. But can I place it here? Yes, I can, because there's no way the three queens are attacking each other, right? There's no way. Okay. So this is third queen. Let's go for the fourth queen. So can I place it here? No, I cannot. 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 So I'll have to backtrack the position of third queen. Can I place the third queen here? No, I cannot. And can I? No, I cannot. So I'll have to backtrack the second position of the queen. Okay. And hence I there's no further space, right, on the second row. So I cannot place this particular queen also here. So I'm going to try here. I have backtrack all those. I'm going to try here to place. The first queen is placed here. Second queen, can I place here? No, I cannot. Can I place here? No, I cannot. Can I place here? No, I cannot. Can I place here? Yes, I can. So the two queens are not attacking. Let's see for the third queen. Can I place here? Yes, I can, because no way these three queens are attacking each other. Okay. The fourth queen. Can I place here? No, I cannot. Can I place here? No, I cannot. Can I place here? Yes, I can place here the fourth queen, right? I can place here the fourth queen. Okay. So what? So here, so we got one combination wherein we can place the four queens in such a way that they are not attacking each other. So what we are going to do? We are going to hold. For example, for each combination, will be having an n size array. For example, here we have a four size array, and and each element, each position will represent the row. Okay, so for example, zeroth row, first row, second row, third row, right? Zeroth row, first row, second row, and third row. So we have each position is going to represent the row, and each element, okay, each element in this array will represent the position of the queen placed in the column. So here we're going to use one based indexing, as this problem is asking one based indexing. Okay, so what will be the one based indexing? 1, 2, 3, 4. So I can say on the first row, the queen is placed in the second column, right? I'll write here. Similarly, for this particular second row, the queen is placed on fourth column. I'm going to write here. Okay, on the third row, the queen is placed on the first column. I'm going to write here. And the fourth queen, it is placed on the third column. I'm going to write here. Okay, so we have one combination. Okay, so we whatever combinations are there, right? So we're going to add them up in the resultant array of array. Okay, resultant array of array. Okay, so here we have first combination. Similarly, now, for example, let me erase this. Let me erase this. So what was it? So let me write here 2, which is second column for in the first row, 4, 1, and 3. This is one of the combination. Now what are we going to do? We found one combination, right? Let me again erase this, erase this, erase this, erase this. So similarly, I'm going to try again. Okay, whether we have more combinations or not. We are going to do in that way. So I just did backtracking, right? So once, for example, if we are done with the position, so we are going to keep on backtracking and we are going to try the next column. Okay, the next column. Okay, and so on. So we have to return all those combination. I hope you've got the problem. Okay, now let's see how we can solve this problem. Okay, so I think I'll code. So I think you'll understand better. So first I'll show the Java code followed by C++. Okay, so what we're going to do here now is we're going to take a help function. Okay, we're going to pass n. We're going to pass n and we are going to pass uh let's say this answer array list. Let's take an answer array list, integer answer. So first I'll show Java code followed by C++ array list. Okay, and also one more thing we're going to take. We're going to take a this for example, for each combination, right? For example, there can be multiple combinations of n queens to be placed, right? So for each combination, we are going to have this temp, right? As I said, I had shown that particular array, right? I had shown that particular array. So we're going to take this temp, a new array list, okay? And we're going to initialize with this list with int I equal to 0, I less than n plus plus I with 0. Temp dot add, we can say 0, okay? So we have an answer. We are going to pass temp and we are going to pass row as well. Okay, row as well. Okay, so we're passing the first row, which is the 0th row, definitely. Now let's see. Let's implement this uh, help function. So int n we have. So just be with me to understand what we are doing here. Okay. So here we have our answer, and then we have here temp, and then we have here our row, right? Int row. Okay. Now what we're going to do here, let's have the first base condition. So what that base condition, for example, if row reaches n, that means we have found one combination. Just be with me, you'll understand again this base condition. If row has reached the n, the size n, that means we have found our first or one of the combinations, right? Okay, we are going to add that particular temp, right? This temp holds each combination, right? Each combination. So we're going to add in the final answer, and then from here we are going to return. Okay. So this help will be a recursive function. Okay. So what we're going to do here, we are going to start with the column equal to 0, column less than n, plus plus column, plus plus column we have taken here. Okay. Now what we're going to do here, we are going to say if can a queen be placed? Can we put a queen? Okay, can we put a queen? So what are we going to pass in that particular queen? We're going to pass this n first of all. Let's write this way: row and column, right? Row and column and we are going to pass this temp as well and n as well. Okay, so at this particular row and column, we are saying can we can we can we place a queen? Can we place a queen? Okay, so if we can place the queen, so what we're going to do? We are going to call the help function recursively. Okay, okay. So yeah, so for example, what we're going to do, temp of, for example, if we can place, right, a queen, what we're going to do, temp of row equal to call plus 1. Why call plus one? As I said, we want to have one base indexing. So you know, right? For example, what was the combination earlier? What was the combination earlier? So the combination was first queen was placed here, second queen was placed here, third queen was placed here, and fourth queen was placed here. So what we're doing here is temp of row, right? What we're doing, which is temp of row, temp of row. Row is what? Row is one here. Row is one. Okay. And we are saying call. Call is also what? Call is call is also one, right? Call is being zero based indexing. But what we are doing is call plus one we are doing. Since we want the elements in the one based indexing, right? So what we are doing here is, sorry, row will be zero, not one. Temp of zero, right? Row, this is the row. So what we are doing here is we are writing at the zeroth row, where is the queen placed? She is placed in the second column, which is this column, second column. That's what we are doing, right? Call was one, one plus one, two. So we are saying, so the queen is placed here. Similarly, here the queen is placed at the on second row, the queen is placed on the fourth column. On third row, for third row, the queen is placed on the first column, and fourth row, the queen is placed on the third column. So this was one of the combination, right? So that's what we are doing here. Temp of row. For example, if a queen can be placed, right, at a certain position, that is row and column, right, at a certain position, then we need to add temp of row equal to call plus one. So this can put, we'll implement this. It checks whether the queen can be placed at this particular row or not, at this particular row and column or not. Okay. So here, so we have temp row. Once we have this, we are going to again call the help function recursively. Okay, help function recursively for the next row, right? For the next row, we want to check. So what are we going to do? Help function. We're going to pass n. We're going to pass answer. We're going to pass temp, and we are going to pass the next row, which is row plus one. I hope you're getting. So once it will keep on calling recursively. So once this combination is done, right? Once this combination is done, we called recursively for this particular row, for this particular, for this particular, for this row. Okay. So once it reaches n, so row, right? For example, row will reach n. Row, since we are row is starting from zero, right? Row was starting from zero here. We are incrementing row plus one here, right? And at certain, for example, if all the combinations were met, then row will be equal to n. Row will be equal to n. Okay, so row will be equal to 4 at some point, right? After 2, 4, 1, 3, row will be 4. And once it reaches, then we are adding this temp into the answer variable. This temp into the answer variable. So what was, so we placed 1. This is answer, for example, 2, 4, 1, 3. Okay. Once this combination is done, now we want to backtrack again. So in order to find the next combination, so we are going to backtrack. We want to backtrack again. So what are we going to do after help, right? It will go on recursively with help, right? So for example, if this was a temp, right? So we are keeping on calling help, right? So we place this the queen at this particular row, then we check for the next row. Okay, the queen was placed at fourth column. Then we again call the help function recursively. It was placed at first column. We again call the help function recursively. We place the this queen at the third column. Okay, and then again we called help recursively, but our base condition was hit here, right? And it added temp. That means we had found a combination and we returned from there. Once we return, right? Once we return, kept on calling recursively. We want to backtrack in order to find the next combination, right? So we're going to say 0, 0. So while backtracking, it is going to be 0, 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 right? So again, we are going to start our queen placement from here for the next, and we are going to find out the next combination. So I hope you're getting this. Okay. So yeah. So at the end, what we're going to do? At the end, we are going to return return uh return answer. Or wait, for this particular matter, we don't want to return from here because it returns void. Here we have to return answer. Okay. Now comes the main business logic here. Okay. The can put. Okay. So what we're going to do, for example, let me draw here again. For example, this is the 4 by 4, right? 2, 3, 4. Okay. This 1, 2, 3, 4. Okay. Now let's say in the first row, we had placed our queen here, right? And then we incremented, our row is pointing here now, which is row 1. Okay. Now we'll be having a column, as you know, we'll be starting from here, call 0, right? Now we want to place the second queen in this particular row. Okay. Now, how to check whether the queen can be placed here or not? How can we check? Okay, how can we check whether the queen can be placed here or not? So we'll check in three ways. Okay, we'll check how we are going to check. We're going to check first this diagonal, then the vertical up, and the this particular diagonal. Okay, that means, for example, if we are at this particular position, we're going to check whether in diagonally up, whether the queen is placed anywhere here. For example, is the queen here, right? Or we're going to check vertical up. Okay, it can be up like till zeroth row, right? And this diagonal as well. Okay, okay, if there is, if nowhere it is matching, either this diagonal or this diagonal or this diagonal, then we can place a queen here. For example, can we place a queen here? No, because diagonally it will be attacking. Can you place a queen here? No, it will be attacking here. Can you place a queen here? No, it will be attacking here. Right? So can we place a queen here? Yes, we can place a queen because it is not attacking anywhere. So here we're going to try three conditions, whether it is attacking or not. And attacking in the sense what? For example, if we were here, right? If we were placed here and we want to check, right? Diagonally, is it attacking? So yes, if you see diagonally it is attacking, right? So we cannot place a queen here. Okay. So we're going to check the three directions, in three directions, whether there is any conflict, whether a queen is placed on that. Okay. In these three directions. If they're not placed, then we are good. Otherwise, we cannot put our current queen here. Okay, so let's write those three conditions. So that means you have to implement a can put function. Okay, so boolean, it will return boolean can put or can place. Let's name it better, can place, right? Can place. Okay, so here what will we want to pass? Int row, int column. Okay, int column. Then we have to pass our temp as well in order to check integer temp, comma, that's it, right? And n, we want to pass n as well. Okay, now what we're going to do, we want to go diagonally. First, we are going to implement this particular thing diagonally, wherein, for example, if we are here, right, at this particular position, so we want to check this particular square, this particular cell, right? So we are here, for example, row is here, column is here. So we want to, first we'll check this particular cell, whether there is a queen placed or not. So for that, we'll have to do r minus 1 and c minus 1, right? R will be placed here and c will be placed here. We want to check here. Then once it is not placed, we are going to check this particular cell. R here, C here. R minus 1, C minus 1, we'll have to keep on doing. So first condition, let's take R equal to row, right? And C equal to col. And what are we going to do? We're going to check from the previous cell, right? So we're going to do both R minus minus and C minus minus, right? For example, if you are placed here, right? If we are placed here, then we want to check this particular cell, right? Okay, this particular cell. Or if we were here, right? We want to check this particular cell. So we did R minus 1, C minus 1. Now we're going to check. We're going to keep on going diagonally on the left side, left up, until R is greater than 0 and then C is greater than 0, right? Now we're going to check here if temp of row equal to or, for example, R equal to C plus 1. If this is the case, then that means we cannot place a queen here because diagonally the queen is placed over there. Then we are going to return false. I'll explain this. Let me explain this. For example, if we are here, right, for this particular second queen, if we are at this position, so now our R is here and C is here, right? And so what was temp written in the first row? For example, this was a temp, right? This was a temp. And in the first row, what was the position of the queen? It is 2. It is 2, right? If you see zeroth row, 0, 1, 2, and 3. 0, 1, 2, and 3. Zeroth row, queen is placed at second column, right? Second column, since one base indexing, right? Now we are checking here, R and C, we are here. We want to check, since we are here, right? We want to check whether the queen can be placed here. And for that, we'll have to check diagonally up, left up, right? So here the queen is placed. And how we're going to check here? So we're going to say temp of R, which is 0, temp of R, which is 0, right? After doing minus minus, temp of R, here, right? Let me, what happened? R is 0 and C is 1. R is 0 and C is 1. So temp of R, right? Which is 0 equal to C plus 1. C is 1. C is 1 here, right? 1 plus 1 we are checking, right? Because being 1 based indexing, C plus 1, 1 plus 1. So C is 1, R is 0. So temp of 0, is it 2? Yes, it is, right? It is. So hence we cannot place a queen here. And hence we are going to return false. We cannot place a queen here. That's what we are saying. Okay. If we didn't find the queen here, then we are going to check for the left up. We are going to go diagonally left up more in order to check whether it is placed or not. So for that, we are going to check R and C. And till when we are going to run our while loop, R greater than 0, R greater than equal to 0, C greater than equal to 0. If this fails, right, that means left up at least the diagonal is that particular queen is not placed here. Okay. Now once it is done, we're going to check for the vertical part. We have checked for this particular part. Right now to check the vertical part. For this, let's initialize this again. C equal to call, right? Since this was modified, now we want to check. For example, if we are here, right? If we are this particular cell, now we want to start looking from the previous row, right? If there is any queen, we're going to check from this previous row. Or for example, if we were here, right, in this particular cell, so we are going to check these two rows, right? These two cells. We are going to check these two cells. So we are going to check from here first, right? Is the queen placed here? No, it is not placed here. Is the queen placed here? Yes, it is placed here. So we are going to write that. So what it will be, since we are going to vertically up only, so we will only deduct or minus row, right? Column will be constant. We're going to check here again, temp of R, if it equal to C plus 1, right? Same. If it is, then we are going to return false if the queen is placed here, right? And otherwise, if the queen is not placed, we are going to deduct or decrement R again. We're going to decrement R. Okay, we won't touch C because we don't want to check for C, right? Okay, so we checked here, right? R, there was no queen. Now we are going to check here. R is here, R is 0, C is 1. Again, so R is 0. So temp of 0 equal to C plus 1 we are doing, right? C is what? 1. 1 plus 1, 2. We're going to check here. Is it right? Do we have queen? Temp of R. Temp of R, temp of 0. Is it 2? Yes, it is 2, right? It is 2. So we're going to return false. Okay. And finally, the third condition, the diagonally right up. This particular diagonal, right? This particular diagonal. So again, R equal to row, C equal to column. And we want to go the previous row, right? Minus minus R. But we want to increment C. For example, let me explain this. If we are at this particular cell, right? We want to check whether queen can be placed here or not. Second queen can be placed here or not. So what we're going to do, we are going to decrement R, but we are going to increment C. C was here. R and C both are 0. Sorry, let me check. Let me explain this. Let me again explain this. So here, what is the condition? We have this chessboard. Okay. So here is our queen place, right? Our row is here, which is 1, 0, 1, 2, 3. Okay. Our queen, a column is, just hold on. A column is 0, right? We want to check. Now that for the next queen, we are starting from 0th column, right? And which is the row? Row is 1. So R is 1, C is 0, right? C is 0. But we want to check diagonally, right? Whether in this particular diagonal is the queen placed, right? Because if the queen is placed diagonally, we cannot place a queen here. Otherwise, they will attack. So for this, what we want to do? R is 1, C is 0. You want to check in this particular cell, right? Diagonally up, right up. So what we're going to do, we are going to decrement R to 0, and this will increment plus 1, right? Because we want to go here, right? C is 0, C 1 for this particular cell to check, right? And that is why for this condition, we are doing C plus 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 C. Okay, while R greater than equal to 0, since we are decrementing the row and we're incrementing column, right? So C will be less than N, or right, or temp dot size, we can say temp dot size. Temp dot size is nothing but again N. Okay. Or sorry, for example, greater than equal to. It shouldn't be greater than equal to, right? It shouldn't be, it should be less than temp size. Okay. So here again, we're going to check temp of R if it equals C plus 1. If it is the case, then return false. Now again, why? So for example, what is temp? Here R is 0, C is what? C is 1, right? So what we are checking? Temp of, and what was the case? Our temp is what? At 0th row, queen is placed at 2. 1, 2, and 3. So what we're checking here? Temp of R equal to C plus 1. Is it temp of R equal to C plus 1? So what is R? R is 0. Temp of 0 equal to C is 1. 1 plus 1, 2. Is it equal to temp of 0? Is it equal to 2? Yes, it is 2. That means we cannot place a queen here. So we're going to return false, and we're going to decrement our R and increment our column. Since we want to go diagonally right up. For example, if we were in this particular cell, a queen is placed here. So we'll start from this R and we'll start from this particular column, right? This cell. Then this, if this the queen is not placed here, we are going to decrement R, we are going to increment C. We're going to check this cell. If the queen is not placed here, we're going to decrement R and increment C. Is the queen placed here? Yes. And then we cannot, in this way we're going to do. Okay, so we're done with the three conditions. If at the end, if these three conditions are failing, that means it is safe to place our queen here. So we're going to return true. We're going to return true. Okay. I hope you have got the solution. So here can place, right? When it returns true, that means a queen is safe to place, right? And we are going to add that particular column plus one, since it is one based indexing, to that particular row. Okay, in that particular row, in this particular column, one based indexing, we can place our queen. That's what we are doing. And once everything is done, we found one combination, we are again backtracking it to find the next combination. Okay, so thanks for watching. I hope you have got the solution. Let me return the answer. Let me compile this. I hope it should compile. Okay, we found some error. That's fine. What is that error? Okay, my bad. Minus it should have been. Let me compile this again. What is the error here? Illegal start of expression. 65. What is illegal start of expression? Okay, these are separated. Check. Oh, we found temp array required. But we found, oh, we have to check like this. If get R, right? Get R. It's not an array, it's a list, right? Dot get R. Again here, dot get R, right? Do we have more here? Can place is good, I think. Let's see here again, right? We'll have to write dot set row with this one, right? Again, dot set row with 0, 0. Are we done? Lot of errors. Okay, we have some issues. What is the issue here? Temp dot set row equal to, what is the issue? C plus 1, C plus 1, C plus 1. Answer temp. Everything is good. What is the issue here? Let me check. Okay, so one of the mistake here is it should be less than, right? In order for the while loop to run, right? C less than should be temp dot size. And let's compile this. It's still 0. What is the error here? We are adding temp. Okay, so we have to add a copy of temp, right? Otherwise, because if we add the original temp, then at the end it is going to be 0, right? It is going to be 0. So to add the copy of temp, let's compile this. Okay, let's submit it. Okay, thanks for watching. I hope you've got the solution. Please subscribe to the channel, like the video. Let's quickly see the C++ code. It's the same. Like let's quickly do a walkthrough. And as anyways, I'm going to attach the code in the description section. So we have our a vector of vectors answer. We have this per level or per row, or sorry, not per row. One of the combinations. In order to have that combination, we have the stem vector. Then we are calling help with zeroth row, right? And what we are doing here is we are trying for each column for that particular row. For a particular row, we are trying each column whether the queen can be placed. And this is a function can put or can place, which will let us know whether the queen can be placed. If the queen can be placed, then for that particular row, add the position. And since it is one based indexing, we have to add +1. Okay. Once we are able to place the queen, then for the next queen, we have to go for the next row, which we are doing row +1. And once we have, for example, we have found all the combination, like one of the combination, then we will backtrack. Okay, backtrack. Okay, to find the next combination. Okay, and let's quickly see this can put function. So we have three conditions here. We are checking for the left diagonal up, we are checking for the straight up vertical and right diagonal up. So these three, if none of the uh, while loops are violated, that means we can place a queen, we will return true. Okay, so this is a solution. I hope you have got the solution. Thanks for watching. Please subscribe to the channel, like the video. I wish you a very happy, healthy, wealthy, and a great day. Thank you so much.